So, um, I think we are we are done with the telescopes. So we should just try an example on them. So let's try this. It says the telescope made of lenses 5 centimeter and 2.5 centimeter is to be made. Find the maximum distance between them so that they are used to view distant objects. Now you know that when you use something to view distant objects, the distance from the of the object will be infinity, right? So automatically the distance of the image from the eyepiece is going to be equal to the focal length of the objective. Sorry, from the objective. It will be equal to the focal length of the objective because the image will be formed at its focus. So that is 5 centimeter. Right? So let me show you what they mean by this. And this is the objective, which is bigger. This is the eyepiece, which is smaller. So I know that both of them are convex because both of them are positive, right? Now what's going to happen? So when the image is coming, it forms at where? At the focus of this. Now we need this to form a virtual image, right? So that means that where this image is falling must fall inside the focus of this. So that means that this distance, at least it must be equal to the focal length of the eyepiece before it can enter. If this distance of the image from our eyepiece is bigger than its focal length, it will not be able to form a virtual image. It's not going to be able to form a virtual image. So that means that since it is the maximum distance that they are asking for, so we are going to take this distance, which is also the distance of the image from the eyepiece, right? As UE. So we are going to take our UE to be equal to what? We are going to take our UE to be equal to the focal length of the eyepiece, which is what? 2.5 centimeter. So what's now going to be the length? The length is the sum of the distance of the image from the objective plus the distance of the object from the eyepiece. So that's going to be f0 plus fe. Now anytime that you are just adding the two foci, you are doing it, it means the telescope is at normal adjustment. So you just do 5 plus 2.5, which is what? 7.5 centimeter. So that's going to be the length. And you can also find the magnification. And the magnification is what? f0 over ue, right? So focal length of objective is what? 5 over ue is still fe in this case, which is 2.5. So which is what? 2. So the magnification is going to be 2. Let's try another one. So what are we going to do to this question? We should find the distance between them, right? So this is our telescope, right? Although we don't need to draw the diagram, I'm just drawing it so as to show you what is going on. This is the objective, this is the eyepiece. So let's assume that the image is here. And the distance, because the image is we are using it to view a distant object. Don't forget that a telescope will always be used to view a distant object unless the question states otherwise. That's when you won't take it like that. So this distance, you know that the image will be formed at its own focus, right? This is the focal length of the objective. But this will not be the focal length of the objective. It will be the distance of the image from the eyepiece, which is its own object distance, right? So that means that the length is just what? f0 plus ue when you are using it to view a distant object. So this is what you are trying to find. So the length is going to be f0, focal length of the objective is what? 20 plus ue. They said it's 20. Now even if they didn't tell us, we know that the bigger one is the objective, the smaller one is the eyepiece. Now we need to find the distance from the eyepiece, right? So we now do that for the two cases. So for the first case, with the eye relaxed, when the eye is relaxed, what's going to happen? So when the eye is relaxed, that means the final image is at what? Infinity, right? So if the image is at infinity, it means that the object must have been at its own focus, right? So that means that UE is going to be equal to what? FE. All these conditions are things that you should know. We have talked about them before. So for it to form image at infinity means the object is placed at its focus. So that means UE is going to be equal to its focus, which is what? 5 centimeter, right? So we just come here, this is going to be 20 plus 5, and that will be 25 centimeter. When we are using to view distant objects, please, that's why we took this to be f naught, because you know that the image will be at its own at its own focus, right? So now what's going to happen? So we are still using it to view a distant object, but the image, when the eye is stressed, so what's going to happen when the eye is stressed? That means that our V is going to be what? 25 centimeter, right? The final distance is 25 centimeter, but it's negative because it's forming a virtual image. So we need UE. So we say 1 over FE equal to 1 over UE plus 1 over VE. So this is what? 1 over 5. Is that 5? Yes. 1 over 5 equals 1 over UE minus 1 over 25. So let's see what we get for UE. So that's 1 over 5 plus 1 over 25. We do the inverse. We get what? 4.17, right? So that means that the length is going to be what? 25 plus 4.17. So 25 plus 4.17, that was 29.17 centimeters. So this will be the length. But all these are what? Given that it is viewing objects that are very distant. I don't mean that the object is not distant, then this is not going to be the case. This is not going to be the case if the object is not distant. So let's try another example. So let me do more to this question. Like, let me find the magnification. Let me find the magnification. The magnification is what? F naught over UE, right? So F naught is what? 20 divided by 4.17. So the magnification is going to be 4.79 or 4.8. So let's do this question from college fees. It says a telephoto lens is made up of a positive lens or focal length 3.5 centimeter. So focal length of the objective is 3.5, and it is placed 2 centimeter in front of a negative lens is 2.5 in front of a negative lens. So that's the eyepiece. Let me change. This is Galilean minus 1.8 centimeter. So what are we going to do? Locate the image of a very distant object. Locate the image of a very distant object. So that means that the object distance from the objective is infinity. So automatically the image distance from the objective will be f naught. Don't forget that will be 3.5 centimeter because it's going to form at its focus, right? Now look at this. So the object is forming at 3.5 centimeters, right? Now what's the focal length? The length, that's the distance between them. The distance between them is 2.5. So what's going to be the distance of our image from the objective? Look at this. Let me try to show you what is going on. So from here to here, so the distance between them is what? 2.5 centimeter. Now this distance is what? 3.5 centimeter, and the image is forming here. So what's going to be this distance? That's just going to be 3.5 minus 2.5, and that will be 1. So that will be 1 centimeter. So that's the what? That's the distance from the eyepiece, 1 centimeter. But don't forget that this is going to be a virtual image, because the image was not really formed. So that means that our UE is going to be minus 1 centimeter, because based on the diagram that we drew the previous time, the image will not be formed at this point, because when the rays are coming to form the image, they are going to do us, instead of them to converge, they will diverge. So the image is not really located at this particular point. It is the final image that we will see, and not this particular image. So that's why this is -1. So we are looking for the image distance. That's VE is unknown. So what's going to be the image distance? So we say 1 over FE equals 1 over UE plus 1 over VE. So 1 over minus 1.8 equal to 1 over minus 1 plus 1 over VE. So I'm going to have we have plus 1. So this is going to be we get VE to be equal to the inverse of this. Let's see. So we do the inverse, we get 2.25. So I'm not sure that answer is correct. So this is 39.27. So the answer is wrong. So that means that I have made a mistake somewhere. Okay, where did I make mistake? The length, the focal length is 3.5 centimeter. Yes, it is 2 centimeter in front of a negative lens. Oh, that's why I made mistake. This is 2 centimeter. So 2 centimeter, 3.5 minus 2, that's 1.5 centimeter. So this should be 1.5 centimeter. So if this is 1.5 centimeter, so here it's supposed to be 1.5. So I should get the answer like this. So yes, so this is 9 centimeter. So this is going to be the final answer. Let's try the second one. It says an opera glass has an objective lens of focal length 3.6 and a negative eyepiece of focal length 1.2. Focal length of eyepiece is what? Minus 1.2. So how far apart must be two lenses be to view the image of a distant object at 25 centimeter from the eye? So that means that the object is distant, that's at infinity, but we are viewing it at 25 centimeter from the eye. So that means that the position of the final image from the eyepiece is what? 25 centimeter, and this is minus 25, right? Now don't forget how the diagram looks. We have the objective, we have the eyepiece, right? So the final image is somewhere around here. Don't forget, the final image is somewhere around here. So this distance is what? 2.5. This is the distance of the final image, right? This is the length. That's the distance between them, right? Then you know that since this is at infinity, you know that the image we want to form at its focus, right? So let's say from here to here, so the focus is at 3.6 centimeter. So let's say from here to here is about 3.6. So this is where the first image is supposed to be formed. So we are looking for this length. So let's see what is going to happen. So the first thing we are going to do is to get this distance. Now look at this. You know that if we know this small distance, which is the distance of the image from our, what do we call it, the distance of the object from our eyepiece. This is the distance of the object from the eyepiece. That's UE. So if you know UE, you just remove it from 3.6 and we get the length, right? So from what I have drawn here, you see that L plus UE is equal to 3.6, right? From here to here is L, from here to here is what? UE, right? So let's do that. So we are going to have 1 over FE equals 1 over UE plus 1 over VE. So this will be 1 over minus 1.2 equals 1 over UE plus 1 over minus 25 centimeter. This should be 25, not 2.5. So we are going to have 1 over 1.2 plus 1 over 25. So you have what? Minus 1.26. Why am I getting a negative answer? Let me try it again. Yes, the answer is still negative. So I think it's negative because yes, it was a virtual image, right? So that's 1.26. So that means UE is equal to 1.26. So that means L plus 1.26 equal to 3.6. So L will be what? 3.6 minus 1.26. So 3.6 minus 1.26, that's 2.34, which is the correct answer that we are supposed to get. So this is the solution to the question. So does it agree the length we have always calculated? Okay, so we should take note of that. So this is the end of optical instruments.